Good morning, good afternoon, good evening, wherever you may be watching this video from. This is Cornelius Tubinda with another video. And in this video, we're answering the 2024 paper 2, question 1 to 5. Okay, additional mathematics GCE. As we can see there, written on a Thursday. All that information, 2 hours, 30 minutes. Okay, a formula of leaf right here. Yes, mathematical formulae there. Yeah. Then we have question 1, which says solve the following systems of equations. It's carrying 6 marks. So for this question there are various methods, but I believe the most efficient and the easiest is the substitution method to solve these equations. So let's get on the answer. 2x minus 3y minus z. Okay, so question 1 right there, we are going to say 2x minus 3y minus z is equal to 4. Then 2 is equal to a 4. Then x plus 2y minus 2z. So x plus 2y minus 2z is equal to something. Here we said it's equal to 4. There we'll say is equal to negative 5. Then we'll have 4x plus 3y plus 2z. As we can see there, 4x plus 3y plus 2z. This is 2z is equal to something. Here we said is equal to a negative 5. That's like that. Then 4x plus 3y like that. 4x plus 3y plus 2z is equal to a negative 10. Is equal to a negative 10. And then we do that. Okay, we name our equations. I'll simply call this our equation 1, this is our 2, then this is our 3, like that. Okay. Then let me just clean out that part. So this is our 2 and then our 3. So to continue, which letter is most suitable to make subject to the formula? I'll make x subject to the formula in equation 2. So I'll say, let x be equal to negative 5. Write the statement, let x be equal to negative 5. Let me look at the equation. Okay, negative 5 minus 2y, negative 5 minus 2y, and then we have plus 2z in, we'll say, equation 1. So let x be equal to negative 5 minus 2y plus 2z in equation 1. So it means we're going to have 2x, x is that expression. So 2, minus 2y plus 2z in equation 1. Okay, so you have what? You have a 2, negative 5 minus 2y plus 2z, that's your x, and then you're going to have minus 3y minus z. So minus 3y minus z is equal to positive 4, like that. Then you just simplify. So we're going to have negative 10 like that, minus 4y plus 4z minus 3y minus z is equal to 4. Group like terms together. We're going to have negative 4y like that, and then we get the negative 3y. Then you're going to have positive 4z, negative z plus 4z minus z like that. The constant terms, negative 10 minus 4. Oh no, let's not do it like that. Let's say is equal to 4 plus 10. Yes, like that. Then it's going to be a negative 7y, and then plus 3z is equal to 14, as this is the fourth equation that we have created. Let x be equal to negative 5 minus 2y plus 2z in equation 3. So it's going to be 4 multiplied by this expression. So we have 4x, so 4 negative 5 minus 2y plus 2z, that's 4x, and then we have plus 3y plus 2z, yes. So plus 3y plus 2z, let me just write the z nicely. 2z is equal to, I believe, a negative 10. Let me just confirm. Is equal to a negative 10. And then you start simplifying accordingly. We're going to have a negative 20. Then multiplied by, negative 20 minus 8y plus 8z plus 3y. And they have written that 3 plus 3y plus 2z is equal to negative 10. Group like them together, the y's, negative 8y plus 3y, so you can just simply do like that, and then the z's plus 8z, then here we have plus 2z, then we're going to say is equal to, we have a negative 10, we have a negative 20, negative 10 plus 20. If we do our algebra properly, we're going to have a negative, no, not negative 7, pardon me for that, negative 5y, you're going to have, okay, so there is going to be plus 10z is equal to a positive 10. We divide throughout by, a 5, you're going to have a negative y plus 2z is equal to a negative 5 plus 2z is equal to a 2, because we're dividing by 5. Then this will be our equation 5. Let's just confirm our working. We simplify accordingly. We had negative 5 as the results there. Then we had the positive 8z, 2z, then we have negative 20. I believe that's okay. Then we solve 4 and 5 simultaneously. Negative 7y plus 3z. Okay. Yeah. So let's go for that one. Negative 7y plus 3z is equal to something. Then we have negative y plus 2z is equal to 2. So here it's equal to what? The fourth equation, 14. So here I have a 14. Okay, I didn't see that space was running out. Let's do this on the top. Yeah, is there enough space at the side? Not really. So let's go to the next page. I'll start with this bottom equation. Negative y plus 2z is equal to 2. Negative y plus 2z is equal to 2. Then the top equation is negative 7y plus 3z is equal to 14. Negative 7y plus 3z is equal to 14. Like that. So you can just, solve this according to whichever method you want. So negative 7 there, multiply the top by negative 7, the bottom by positive 1. Yeah. It will become positive 7y minus 14z now. Okay. Is equal to a negative 14. Then this one just maintains how it is, negative 7y plus 3z is equal to 14. Yeah. Okay, so to continue, here we're just going to add, okay, add across, we add so that the y's can eliminate themselves, then we remain with this is a negative 11z is equal to negative 14 plus 14 is 0, so divide by negative 11, divide by negative 11, z is equal to 0, like that. And then we will let z be equal to 0 in equation, this was equation 5. I think equation 5 is the simplest. Okay, so we have the negative y plus 2 times 0 is equal to a positive 2. To continue, negative y is equal to positive 2 divided by negative 1 divided by negative 1. Y is equal to a negative 2. Let's just confirm our answers. So here we multiply by negative 7. Did we do our algebra properly? Yes. It became like that. Okay. Then we'll just say, let z be equal to 0, y be equal to negative 2 in x. Then x, okay, the document is trying to save itself. Could I find it? Okay, let's try to do something here. Okay, document has been found. Okay, let z be equal to 0, y be equal to 2, negative 2 in x. Okay, what is our x? Let's go back. Our x was x equal to negative 5 minus 2y plus 2z. So x is equal to negative 5 minus 2y plus 2z. So this will be equal to negative 5. Here we're going to have a positive 4, 0. X is equal to a negative 1. So let's just confirm the equation. This is a negative 5 minus 2y plus 2z. Okay. When you do your answering like that, just say therefore x is equal to negative 1, y is equal to what? Negative 2, and then z is equal to 0, like that. Yeah, so the next thing will be, when you find suspicious answer like z is equal to 0, you go back to your equation. So let's just know the answers. X is negative 1, y is negative 2, z is 0. If we go back to the equations, let's start proving. So 2 multiplied by negative 1 minus 3, y is a negative 2, and then z is 0. So it's going to give us a positive 4. Try to substitute. It's going to give us a positive 4. Okay. And then we have x, which is a negative 1, plus 2, y, which is a negative 2, and then minus 2, z, which is a 0. You are going to have a negative 5. 4 multiplied by x, which is a negative 1, then plus 3, y, which is a negative 2, then plus 2z, which is a what? 0. Going to have a negative 10. So this is just one of the solutions to whichever method you would want to use. It gave this solution for this method, as you can see there. Yeah. So we now move on to question 2. A. Find the range of values of m for which 2m squared minus 2m is less than 0. So let's write that. 2m squared minus 2m minus 4. This is question 2a. 2m squared minus 2m, I believe. Just try confirm. 2m squared minus 2m minus 4 less than 0. Minus 4 less than 0. So you need to find the critical values, critical points. We replace the inequality with an equal sign. 2m squared minus 2m minus 4 equal to 0. Divide throughout by 2 here. We are going to remain with m squared minus m minus 2 equal to 0. The constant is like that. And then here, going to have negative 2. Okay. Then to continue, this is a quadratic, m squared. Which two numbers multiply give you negative 2? Either give you negative 1, negative 2m plus m minus 2 equal to 0. Factorize by grouping. Okay. So it's going to be m multiplied by m minus 2, factor out a positive 1, it's going to be m minus 2 is equal to 0. So m minus 2, m plus 1 equal to 0. M equal to 2 equal to negative 1. Then what we do is what? Yes, after finding those two critical points, now what we do is we start testing to prove using 3 regions where it would satisfy the inequality. So you have here an answer which is lower in the number line. So m is equal to negative 1 here, then m is equal to a positive 2 there. And then what you do first of all is you substitute into the 2m squared minus 2m minus 4 is less than 0. Okay, let's try a negative 2. Is it going to be less than 0? A number less than negative 1 is negative 2, so 2m squared, 2 multiplied by negative 2 squared, minus 2m minus 2 negative 2, then minus 4. Is this less than 0? Is it less than 0? 8? No. So 8 is not less than 0. A number between negative 1 and positive 2 is a 0. Is negative 4 less than 0? It satisfies the inequality. So like that. And then we have a number greater than positive 2. It can be any decimal number, but here we can even use a whole number like 3. Okay, or let's use, for practice sake, 2.6. So we're going to have 2 multiplied by 2.6 squared, then minus 2 multiplied by 2.6, and then you're going to have minus 4. You have a 4.32, which is not necessary, but it is positive. It's not less than 0, so like that. You therefore draw to a conclusion. Therefore, the range is negative 1 is less than m and m is less than positive 2. Satisfy the inequality. Then we go to the next question. As you can see, I've answered question A. Then question B, express x squared plus 5x plus 6 in that form where a, b, and c are constants. Hence find the coordinates of the turning point. So two-part question, expressing and find the coordinates of the turning point. So x squared plus 5x plus 6. Okay, so we'll start answering our b from here somewhere. We try to see where we can have, I think the space is sufficient. Somewhere here we can write b, not here. Anyways, the space is not that sufficient. Where can we start from? We can start from here, b. So I have x squared plus 5x plus 6 as an expression because it has no equal sign. Okay, x squared plus 5x plus 6, like that. Okay, I've confirmed. First step, that is how we go about it. We factor these two first terms like that, plus 6. And the next thing will be to say is equal to, since we have already made sure that the leading coefficient is a positive 1, and then there we can already see that it's in this proper form, so we can have 5x, then 5 divided by 2 is 5 over 2, then that you square it, it's going to be 25 over 4 minus 25 over 4. Why? To just maintain the validity or validity of this expression. Yeah, plus 6. Can we write a 6 here? 6, like that. Okay, let's put the question comma there. Then we're going to say is equal to, okay, another comma there, so we're going to say is equal to x squared, and then of course all of this expression is in brackets, so we're going to make x squared plus 5x plus 25 over 4, then what is 6 times 4? It's going to give you 24. So plus 24 over 4. 24 over 4 is the same as 6. Then minus 25 over 4. So this part has gone out of the parentheses or the brackets. And then you're going to have is equal to x squared plus 5x. Then this is still supposed to be in brackets, so that you don't get confused. Forgot to put it in brackets, sorry for that. As you can see, that's what I did. I hope you're not confused there. So now we can get rid of the brackets. Okay, not yet. First of all, let's simplify there. So plus 25 over 4, like that. We still maintain, then we simplify what we have there. It's going to be negative 1 over 4, like that. 24 minus 25, yes. And then square root of x squared, x square root of that, which is 25 over 4, is going to be 5, divided by 2. You get the sign of the b there, which was positive in this case, so we're going to put a plus there, then minus 1 over 4. Then it is a good way of concluding. Just check if this is the expression they wanted. Of course, for additional mathematics, they don't ask anything crazy. So it's going to be a x plus a b, the power 2 plus c. So to continue, it's going to be a multiplied by x plus a b, then squared plus c is equal to the expression we found, x plus 5 over 2 squared minus 1 over 4 as your final answer for the first part of the question. Then the second part of the question, the turning point, x plus 5 over 2 is equal to 0, x is equal to negative 5 over 2. We have found x coordinate. Turning point, therefore, TP will be what? Will be negative 5 over 2, comma, negative 1 over 4 from that expression, like that. And if you want, you can even check. You are seeing that the leading coefficient was positive, showing that it was a what? A minimum. That's why this is a minimum turning point. Yes, as you can see there. Then we go to question 3. Okay, we proceed. Question 3. Solve the equations. These are logarithmic equations. Question 3a. 7 to the power, this is 2x plus 1. I believe that's a plus 1. It can't be minus 1. Yes, 7 to the power 2x plus 1 is equal to 13. That's question 3a. Okay, let's proceed accordingly. 3a. So 7 to the power 2x plus 1 is equal to 13. What do? We apply something called the common log to both sides. So say common log of 7 to the power 2x plus 1 is equal to common log, which is just LG, of 13. We use the power rule here. It's going to be 2x plus 1 multiplied by the logarithm in base 10 of 7 is equal to logarithm in base 10 of, we just write the L's property. I am not writing the L's property. Logarithm base 10 of 7. So, sorry. Logarithm in base 10 of 7 is equal to logarithm base 10 of 13. And then to continue, we divide both sides by log 7 because it's when we're writing common logs, we can omit that letter O. So you can just say LG7 divided by LG7, where these cancel out. This is just a very quick method. Then 2x plus 1 is equal to on your calculator you type log 13 divided by log 7. You're going to have 1.3. Okay, so that answer that you have found, just leave it, don't do anything with it. But in your working, you can approximate it to 3 significant figures. You can say 1.32, and then you're going to say 2x is equal to. So now you're going to subtract a 1 from your answer. You're going to have a 0.32. Of course, your x is dividing by 2, which is going to be x is equal to 0.159. This is correct to 3 significant figures. Okay, so this is you're working for question A, and then you can prove accordingly. 7 to the power 2 multiplied by x, which is 0.159, and then plus a 1, they're going to have a 12.99, whatever, yeah, approximately. And then you have your b here. Your b proceeds as follows: log base 2 of x plus 2 is equal to 3 plus log base 2 of x. Log base 2 of x plus 2 is equal to 3 plus log base 2 of x, I believe. Log base 2 of x plus 2 is equal to 3 plus log base 2 of x, like that. Yeah, so I've confirmed this is the correct equation. What we're going to do is we're going to group like terms together. Okay, maybe we can even draw a line here. Can we something like that? We're going to say log base 2 of x plus 2 minus log base 2 of x is equal to 3. Then when you're subtracting logs, you divide. So first of all, you get the common base, which is log base 2. Log base 2, and it's going to be x plus 2. So the expression here that is in front of the log is x plus 2. There it's x. So the x plus 2 divided by x is equal to 3. To proceed here, you need to know the definition of a log. It is the power to which this base must be raised to give you what is inside there. So x plus 2 divided by x is equal to 2 to the power 3. So the base must be raised to, okay? This is in the exponential form, okay? 2 to the power 3 is equal to that. You can cross multiply, yeah, or we can cross multiply. So x plus 2 is equal to 2 to the power 3 times x. X plus 2 is equal to 8x. You factorize, you have 7x. If the x goes to the other side is equal to positive 2 divided by 7 divided by 7, your x will be equal to 2 over 7. Therefore x is equal to 2 divided by 7 as your final answer. So let's just check through the working. So we had x plus 2 divided by x is equal to the base, which is 2 to the power 3, 8. So you cross multiply, it will be 8x, 7 giving you 2 over 7. You can improve right now. So you can use the change of base formula. I hope you know what I mean when I say change of base formula. You can do something like this. You can say log, okay, like that, where I would just say log of x plus 2, so the base there is 10, so log of x plus 2, then you divide by log of what? 2. So your change of base, the base was log base 2 of x plus 2, and then it became like that. Change of base formula. Okay, so let's write that down. Change, let's write it properly. Yeah, so change of base formula. Yeah, change of base formula, like that. So let's try. So x plus 2, x was a 2 over 7. So 2 over 7, type that, plus 2, you're going to have a 2 remainder 2 over 7, which is the same as we can say 16 over 7. Is it 7 times 2, 14? Yeah, 16 over 7. So let's say log of 16 divide by 7, then you divide by log of 2. You're going to have a 1.19 as your answer. Then on the left hand side, you use the same change of base. This one can be written as what? Log of I hope you can see this, log of x, you divide by log of 2. That's how you write it as change of base formula. So log of x, log of 15 divide by what? This was 15 over 15 over 7, yeah, 15 over 7, then divide by log 2. Here we had x plus 2, divide by a log 2. Then here we had the log of 15, divide by 7, divide by a log 2. The answer we find, we add 3. Okay. I hope you have proved that it's given the same thing. Okay, just found out that the x I was using was 15 over 7, but the x we found was a 2 over 7. But if you add properly, you can see that you have 2 divided by 7. So log of 2 over 7, you're going to have negative 1.8, then plus a 3. You're going to divide by 2, of course. Make sure that you divide by 2. Okay, divide by 2. So log of 2 over 7 divided by log of 2, you're going to have a negative 1.8, then plus 3, a 1. What is this? This is a 1.19, which is the same answer we found. Yeah. So I just thought I would just stress that it was not needed, but in the exam, when you have that extra time, you need to prove. Then question 4a. Find the value of m given that this polynomial leaves a remainder of 30 when divided by x plus 3. A remainder of 30 when divided by x plus 3. So we have 2x cubed minus mx squared minus 5x. 2x cubed minus mx squared. So this is our question 4a. F of x is equal to 2x cubed minus mx squared, and then minus mx squared minus 5x plus 13. So you have minus 5x plus is it 13 or 18? Let's just confirm. Plus 18 leaves a remainder of 30 when divided by x minus 3. So the remainder of 30 when divided by x minus 3. So here is supposed to be 18. So leaves a remainder of 30 when divided by x minus 3. So you simply say let x be equal to 3. This just came from the x minus 3. You say so here it's like x minus 3 equal to 0, and then you say let x be equal to 3. That's what we did. Then it leaves the remainder of 30. So it's simply trying to say that f of 3, substitute 3 is equal to 30. Then you just write that down. So a 2, 3 to the power 3 minus m 3 to the power 2. Then you have minus 5, 3 plus 18 is equal to 30. So it's going to be 2 multiplied by 27 minus m, which is a 9, minus 15 plus 18 equal to 30. This is going to be a 54 minus, here we're going to have a 9m, and then there, simple algebra, positive 3 is equal to 30. Everything goes on the other side, or everything comes to this side where we have, okay, so let's try to compute this. This is a 54 plus 3, then minus 30 is a 27. So we're going to have 27 on this side of the equation is equal to 9m crosses to the other side, divided by 9, divided by 9, 9 can go into itself a 1, into itself a 1, into itself a 1, then 27 in the 3. Therefore, m is equal to a 3. Simple as that. And then the next question, so I've answered question 4a. Yeah. Question 4b, given that, yeah, this one is quite involving. This is one of those involving questions. Given that 2x cubed plus 3x squared minus 4x minus 5 is equivalent, okay, 3 equal signs there, 3 dashes there, sorry, is equivalent to px plus q, x plus 3, x plus 1 plus r. For all values of x, find the values of p, q, and r. This is carrying 4 marks as per custom. 2x cubed plus 3x squared. So 2x cubed plus 3x squared. Is there a space this side? Okay, we just go to the next page. So we have b, which is 2x cubed plus 3x squared, like that. And then we are saying minus 4x minus 5 is equivalent to minus 4x minus 5 is minus 5 is equivalent to, so minus 4x minus 5 is equivalent to what? What do we have this side? Px plus q multiplied by x plus 3. Px plus q x plus 3. So you have px plus q x plus 3. So minus 4x minus 5 x plus q x plus 3. And then we are going to have, let's just increase the brightness. Then we're going to have multiplied by x plus 1 plus r. X plus 1 plus r. X plus 1, then r is outside as the constant 10. What do we do? So let's deal with this right hand side of this identity. Let's just yeah, have this. So let's start by multiplying this bracket and that bracket. Then the answer can multiply by this bracket. So we're going to have px plus q, okay, multiplied by x times x, x squared, x times 1 is x, 3 times x is 3x, 3 times 1 is 3. Yeah, like that. So x squared plus x, 3x plus 3. Of course, I've got to include plus r, very important. Let's not forget it. So we are going to simplify this to become px plus q multiplied by x squared plus 4x plus 3 plus r. Then we distribute the px in this bracket, and then to be px cubed plus 4px squared plus 3px. Then distribute the q in that bracket. You're going to have plus, if we revert back to the question, was it cap letter q? I just want to confirm. It was cap letter q. Okay, so if you revert back, you're going to have plus qx plus 4 qx squared plus 4 qx, and then you're going to have plus 3q plus r. Okay, so but dealing with the left hand side first of all. Okay, like that. So px cubed plus a 4 px squared plus a 3px, then a qx squared plus a 4qx plus 3q plus r. And then if you look at this, there is only one term that has a cubed, which is this one here, that term there. We can conclude from the left hand side that 2x cubed is equal to p x cubed. Therefore p is equal to 2, or we can just say it like this, that 2x cubed is equal to px cubed. And then this and that will cancel out. 2 is equal to p, or p is equal to 2. Like that is your first solution. And then now we need to look for q. Now which one can we use to look for q? Such that now we know our p. Okay, so we can continue solving this. So it's going to be p x cubed. Okay, let's group like terms together, but I just wanted you to note down the cubed term. Then plus 4px squared, then plus q x squared plus 4q plus 4qx, like that. So you have your terms like that, 4qx, and then you have your 3px plus 3px plus 3q plus r. So as you can see there, everything that is squared is together. Then what is having x only is together. What is having no constant, no variable is together. And then after that, you know what your value of p is. So you say 4p x squared plus qx squared. 4p x squared plus q x squared, in that manner, is equal to the left hand side of this one, which is 3x squared, is equal to 3x squared. Then we can drop x squared. We are going to have what? 4p plus q is equal to 3. Well, we know the value of p is a 2, so 4 multiplied by 2 plus, just the ordinary work in there. So we're going to have 8. Q is equal to -5. You can use a different method to find the value of Q. I'll show it this side. I'll do them side by side. You could have used the x where, for example, the x term here is negative 4. So let me just to reduce on the time of the video. Let me try to do this fast. So here at negative 4x, let me just try to confirm. The left hand side, negative 4x is equal to we have 4qx plus 3px is equal to 4qx plus 3px. Then we drop x, negative 4 is equal to 4q plus 3p then you're going to have what? Negative 4 is equal to 4q k plus 3p is a 2 as right. Then you're going to have a what? You're going to have a negative 4 is equal to 4q in plus 6. That's right. Then you're going to have the negative 6 goes on the other side. Means that your... Let us continue. Okay, so I was trying to show you another different method of answering this. Trying to answer. And I just saw that this question had a problem where if you use this other method, this method where you are using the... So use all methods, okay? So what do I mean this other method? Here we used x, okay? We had the one containing the coefficient of x here. So here, how can I write this? Let's say coefficient of x, and then there we had one containing the coefficient of x squared. There, coefficient of x squared. So you use this method. Don't use this method because it's like ECZ made a mistake. These things are very rare that ECZ makes a mistake, but it happens. Because if I use this second method, we're supposed to find the same answer. But here, of course, here, just solving this equation here, already you know that this will not give you q is equal to negative 5. Only if p here was a positive 2, you would have had a negative, but we have a positive 4. And the working, if you go through the working, you won't find any mistake. I've proof checked everything. So let's go to find the value of r. So the last part of the question is finding the value of r. What did it say? So negative 5 is equal to 3q plus r. Let's proceed. Negative 5 is equal to 3q plus r. Negative 5 is equal to 3, but I know q is a negative 5 plus r. Then we have the negative 5 is equal to negative 15 plus r. R goes to the other side. You're going to have r is equal to negative 5 plus 15 positive 10. R is equal to positive 10. Therefore, P is equal to 2. Q is equal to negative 5, comma, R is equal to positive 10. So this question is very good. This is why it's very important to practice, past papers to see. In a case where ECZ was to make a mistake like in this year, what do you do? Do you just get stuck and skip the question? Try all the methods you know. You move on. You don't get stuck and you start wondering where. Don't spend too much time proof checking your answer. If you have proof checked, you have been practicing, you have built that confidence, you just move on. Question 5a. In how many ways can 11 men and 3 women be put in a straight line? A1, there are no restrictions. So this is 11 men, 3 women. There are no restrictions. 5a. So let's go to question 5a. A1. The document has saved itself. Let's just wait for it to come back. Question 5, A1. A1. So there are 11 men and 3 women. Well, if you add that together, you're going to have 14 factorial. Big number. They said no restrictions, just add to find the total number of, ways. So 14 factorial is what? Correct to 3 significant figures. 8.7. Or you can write it in standard form, but let's just write it in 3 significant figures. 8.72 times 10 to the power 10. Big answer. But in additional mathematics, we need to be used to such. Okay, so that is, there are no restrictions. 11 men, 3 women. No 2 women are together. No 2 women are together. That's A2. No 2 women are together. What does that mean? It simply means that there should be a man, a man, a woman, a man, a woman, a man, a woman, not a woman next to a fellow woman. That's what I mean. So you can have 11 men, okay? 11 men seated in a straight line. You can have different methods of how to do this. Let me show you one method. So let's write about 12 spaces. So we have 11, and then you also, so 11 plus 12 is what? Is 23. Can I write 23? That's a lot of space. Okay. Anyways, for the sake of learning, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Well, okay, this question, I think this method would discard it, because looking at how the question was phrased, it will take up too much space. So let us just continue accordingly. So we have 11 women, 11 men, not 2 women together. So if you are to arrange 11 men in a straight line, for example, let's use sticks. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 men. How many spaces are here? So the spaces we have are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 spaces. So the way we would do this is that if you want to know the number of spaces without having to do all this, go through that trouble, you simply say the number of men. So you say number of men plus 1. That's all. So it will just give you what? It should give you number of men is 11 plus 1 equal to 12. So there are 12 spaces. I'm just providing, that type of explanation that is needed for one not to ever make a mistake on such a question. These are free marks. This question, you don't even need to sweat. You don't need to sweat. You just need to get full marks. Okay, so it will simply be equal to, we have how many spaces? 12. P means permutate, which just arrangement where the order matters. So 12 permutate 3. 12 permutate 3, the same as saying, in the first space, you put a woman, that woman will have 12 spaces, okay? 12 spaces, but if you go to the first one, so it will be 12, the second one will have 11, the third one will have 10, so 12, so you can say times, other men are 11. or 12 times 11 times 10 times 11 factorial, we will find the same answer. It's equal to what? 12 permutates 3. 12 you permutate 3 multiplied by 11 factorial. You're going to have a 5.27 multiplied by 10 to the power 10. 5.27 multiplied by 10 to the power 10. Or you can say 12 times 11 times 10 times 11 factorial, because the other men can still move, okay? They can still permutate. You are going to have the same answer, so you can prove. That's your answer there. Of course, they ask for the what? They ask for the number of ways. So those are how we do it. Then the last question is B. A group of 4 students to be chosen from 7 males and 3 females. 4 students from 7 males and 3 females. So for question B, so let's just a group of 4 students to be chosen from 7 males and 3 women. So yeah, that's how you do it. 5.27 10. Let's write ways, because they'll ask you what is this answer about. So you're asked to find number of ways. So if that restriction is to be 8.72, then it's the particular restriction. It's supposed to be always less than the one without, because the first one had no restrictions, but this one was inclusive of a restriction. If it gave us a bigger value than what we found in question A1, this one right here, if it gave us a bigger value, just know that we are doing the wrong thing. Okay, so 4 students, 7 males, 3 females, not women. What have I written? Okay, we'll come and correct it. 7 males, 3 females. Find the number of ways of choosing at least 3 males. At least 3 males. So this is 3, not 3 women, 3 females. You can never know, maybe these are girls. So like that, at least 3 males. Let's confirm, at least, you can see there, at least 3 males. So at least 3 males. How do you do this? The total should always give you 4. So 7, so it's equal to, okay, it would be equal to 7 combination at least 3 males multiplied by the number of females is 3. You choose 1, so the total here down here should give you 4, and then 7 males, 3 men, like that. I hope you just take note of that. And then you're going to have plus 7 combination. Now you only have a group where I've just chosen males throughout. So 4 males multiplied by 0 women. So this and this, like that, should give us 4. Sorry. So what are we going to have? Type that into calculator. 7 combination 3 times 3 combination 105 is equal to 105 plus 7 combination 4 multiplied by 3 combination 0, 35. 105 plus 35. This is simple, giving you 140 ways. You see how simple that question was? 140 ways. Just break it down, be calm, be confident, practice. Everything else will be alright. Practice, practice, practice. So at least 3 meals like that. Practice, practice, practice. Thank you so much for watching this video. This is part part 1 in a 3-part series to answer the 2024 paper 2. Then we'll go to mathematics. Thank you so much for watching this video. This has been Cornelius Subinda with another video, and bye bye.